for joining me and our WSB team for today's Snack and Learn. Sorry that I cannot provide you the snacks, but I hope the outcome of the presentation is good enough for you guys to be satisfied with not having the snack with us. Anyways, without any further ado, let's get into our presentation today. I know that for some of you guys, it may not be the best time. It's kind of in the middle of the day for you guys, but thank you for joining and hope you will learn something from today's presentation. For the agenda for today, we go through the introduction. We talk about a little bit of the fire and pool of fire and the risks. Then we talk about probability, hazard, severity, and risk assessment of a fire in the transit system. We talk a little bit about the code and the compliance with NFPA and if we can actually do anything to improve even over and beyond the NFPA code for safety. On the second topic of today, we talk about how we can possibly improve our rolling stock situation for current and possible future pandemic. At the end of the day, we will have a discussion and Q&A. Just for your information, before I get to the presentation, if you're interested, you can download the presentation and some other information from our handouts. It's already there. You can download that. Also, we will have a Q&A session. I appreciate if you actually post any question while we are actually talking and while I'm actually presenting. You can take your time and type the questions. My colleague will gather all the questions and we'll go over them at the end of the presentation. Thank you. Okay, before anything, safety moments. I just want to make it short because it's not a lunch and learn, it's a snack and learn. We only have a very limited time. Hand safety. I'm not really sure if everyone that joining this seminar is from only North America or somewhere else, but anyways, in North America, at the moment, we are starting at the start of the summer. Lots of us will work outside in the gardens, in the backyard, planting this. Make sure you take care of your hand safety. Definitely wear gloves when working outside. Of course, when you're working at a construction site, the safety requirements and gloves is a certain requirement. So, why are we talking about these items today and what would be the outcome, hopeful outcome of today's presentation? We want to actually, if I can, in this presentation is 20 minutes presentation, if I can send you back to work answering these 3 simple questions, I will be more than happy. Is the risk of a major incident fire in transit? It's a real risk. Why are we spending millions of dollars on TVS and FLS or tunnel ventilation system and fire life safety in transit system? Can we do something to improve safety and resiliency during the pandemic? These are the 3 main questions that I'm trying to answer today. So we all have seen stories, we heard stories, we have seen photos and pictures of a fire in underground transit system. The photos that you see on the left side is mainly they're from the South Korea's incident. It happened a decade ago. It was a very disastrous fire incident that happened. We heard stories of different incidents in other locations. Few years back, I guess all of my colleagues in North America remember there was a smoke incident in Washington subway. There was a smoke incident, I believe 2 years ago in one of the TTC lines. We hear this stuff. So because of all of those things, there is a genuine concern and question on what is considered safe or safe enough in a transit system. And we are hopefully trying to answer that question. So what are the sources of the fire in transit system? There are a few major sources, but one, we can actually categorize them in 2 different categories. One is the rolling stock or the vehicle itself. Based on experience from different projects, the rolling stock in transit system, the fire, if they're going through a full fire, the fire will be between 5 to 25 megawatt of fire. Other sources of fire could be trash fire, electrical fire, uh, luggage fire that the passengers are bringing with themselves, or any other external sources. They normally range between 1 to 5 megawatts. And so based on these numbers, you can see that the rolling stock is the major fire that can happen in an underground transit system. But let's look at how big is a 25 megawatt fire. I'm not sure actually if you are familiar with the pool of fire concept. The pool of fire concept is pretty much considered a backyard pool or a public pool filled with fuel, and on the top there is a fire. So there is abundance of fuel underneath and there is fire on top. A 25 megawatt fire is equivalent to 10 square meters. So a pool 10-meter length by 2-meter width, completely engulfed in fire. The fire that you see in this picture on the right side, just make a guess. It's only around 2 to 2.5 megawatt of fire. So a 25 megawatt fire is 10 times bigger than what you see in the photo. It's actually a huge fire. If that happens, hopefully it never does, but if it happens, it's really a very huge fire. So what are we doing in this presentation today? For the first part about the fire, we actually gathered existing information from two reliable sources, UK Railway Safety and Standard Board and Federal Transit Administration, FTA. They both publish the data. You will see the data that we collected are from 2007 and 2015. The time that we were actually going through this analysis, I was preparing something to be presented for 2019 or 20. So the data is from that time. We had pandemics and everything. So because of that reason, the data is a little bit old. I looked at the newer data. I haven't updated it. It hasn't changed much, but definitely in the next version, I will provide updated data as well. But really the concept doesn't change. The concept still remains the same. So to assess the risk, we are using Senelec. There are different standards that you can use. There are even local standards. Some owners or companies have their own risk analysis, but we are using the concept of Senelec. Senelec is basically tells us find the category and the frequency, and then we can find what are the risks of that incident. And this is exactly what we are going to do today. So FTA data. We analyzed the data from 2007 and 2015. Based on the data from FTA, and we actually went through all the data and we find the one that has caused the fatality. The final number is one major fire incident every 27.8 million miles traveled by the vehicle, or 44.7 million kilometers, if you're more familiar with the kilometer instead of mile, like I am actually. I have a better sense of kilometers than miles. So is it good? Is it bad? Is it too much? We will see in a short period of time. The second data that we use, RSSB from British data. Again, major incident with fires. Of course, there are incident with fires and there are major incident that with fire, which is only 3.2% of all of those fires are considered major. So based on that, and believe me, it was just by accident. I did not do anything with the numbers and data, but the number came back exactly the same as FTA data. It's still surprising myself, but that's the reality. So the number came back 20.7 million mile traveled. You will expect one major fire incident or every 44.7 million kilometers. So is it good? Is it bad? How we can make sense of it? It all actually depends on our project and the project that we are working on. So as an example, assume we have a system that is 10-kilometer length. 10-kilometer length is most of the systems that actually I'm seeing these days, newer system or extension system, they are between, say, 5-6 kilometers to 10-15 kilometers. So I chose 10 kilometers just as a number. Makes sense. So for instance, right now in Toronto, I don't know if you're familiar, one of the biggest lines that we are building is Eglinton LRT. It's 13 kilometers underground. Overall is nearly 20 kilometers. There are lots of other extension in GTA that's happening are between 5 to 10 kilometers in length as well. So the number is pretty much a correct ballpark for the projects, but you can actually use whatever your project is going for. Also, for this specific example, I use the headway of 3 minutes, and I assume that the line is in service for 20 hours. So pretty much from 6 o'clock in the morning till 2 a.m. in the next morning, pretty much. Using those numbers, it comes back that such a system, every vehicle in the system will be traveling 2.9 million kilometers per year. If we use that number that we had from the previous one, that we have one major incident every 44.7 kilometers, it comes back that every 15.4 years, we may expect a major fire incident. It doesn't mean that it will happen. It's just a matter of it may happen. It's a very important thing actually to know that it doesn't mean that it is happening, but it may happen. So what do we do with that number? Is the big number, is the back? I guess to me, it makes sense because in my experience, at least 20 years being here, I heard few incidents. Some of them were major, meaning we had to evacuate the whole system. Some of them were not, but to me, actually, the number kind of makes sense. It's in the ballpark of what I expected to see. So for risk analysis, what do? We go to Senelec table. Senelec actually is good because it's very categorically tells you the frequency. Event between 10 years and 100 years comes back to be a remote event. So if it comes back that instead of 10 kilometer system, you're designing a 50 kilometer system, then your number will be 5 times 15 years. It's 75 years pretty much. You're still in this category. So remote is pretty much what you get. If you're designing a 100 kilometer system underground, which I don't think that anybody does, but then your category goes to occasional. So you have to go by project, but for most of the project that I've worked on, we go back to the remote. As far as the hazard severity, a major fire incident could be considered catastrophic or critical. Either or will work. It depends again on the situation, on your background data. You can actually talk with the operators and I don't know, fire department or authority having the jurisdiction in that area to actually make sure that you categorize this properly, catastrophic or critical. I'm not really putting my foot on either of them. Each one could be correct depending on the project and the situation. The reason I'm not really insisting to choose one over either is this. When you go to the risk analysis table with remote, your critical or catastrophic, the risk comes back the same, undesirable. So when the event is a remote event, it doesn't really matter if it's critical or catastrophic. They are all the same category, undesirable. When a system comes back as undesirable, what we need to do is we have to actually make sure we mitigate the system or we mitigate the risk. How do we mitigate the risk? Most cases, we go with codes. We go with NFPA 130, for instance, in North America. Building codes, there are actually European standards. There are different regions have their own. Some of the owners and operators have their own codes and standards. We use that. In the next few slides, what I want to actually show you is few features that, for instance, NFPA gives you to implement and how they work. Are they really changing the situation or not? One of the biggest things that NFPA had, and they actually added that in the NFPA in 2000, was fire hardening material of the vehicle. Pretty much what NFPA is telling us is to all the material that are used in a vehicle needs to be fire hardened. So there needs to be resistance to fire and fire propagation. It gives us a really good result at the end of the day. The Korean fire that I talked to you about and showed you some photos at the beginning, the South Korea's fire, they did a simulation of their existing car that catches fire and a car that has been fire hardened based on NFPA 130. The results was pretty much the difference between day and night. Other features that we have in tunnel in NFPA and a lot of building codes, for instance, in Ontario Building Code, we have the tunnel ventilation requirement. It refers to NFPA 130, of course. NFPA 130 has a very restrictive and specific requirement for tunnel ventilation system. It provides a real good advantage for all the systems. I actually put a video YouTube here. If you download the handout, you can actually click on it and you see how good a nicely designed tunnel ventilation system can move the smoke away from some part of the system and provide you with a tenable environment for egress. Fire suppression and detection. NFPA again has some specific rules and requirements for fire suppression and detection. Are they the best? For public areas, NFPA does not require any sort of fire detection. For instance, in the tunnels, a fire detection is not required by NFPA. For back of the house, they ask for fire alarm, they ask for fire detection and everything. Can a fire detection in the tunnel provide a good feature for safety? It definitely can. However, the fact is it's always a risk analysis with cost and maintenance. So this could be done project by project. It can improve the system. We have the ability to improve the system for fire suppression and detection system, but it needs to be project by project. So every project has to make their own decision that what they want to do. Other features that NFPA, for instance, provides to mitigate the risk are egress and access facilities. NFPA has very good requirement, as far as at least my opinion, regarding the egress, a really nice and wide walkway to egress the system. Probably you have seen that, the coffin shape that NFPA has, 610 millimeter on the bottom, 720 on the shoulder side. So it's actually a very nice big walkway if you have ever were walking in a tunnel during construction and you walked on those safety walkways, you can see that actually the walkway is very nice and safe to walk. Emergency lighting and a lot of other stuff for the walkways and emergency system. One of the things that, for instance, in NFPA 130, I feel like that it can be improved is that there is no really requirement in NFPA that what is the height difference between the vehicle floor and this safety walkway. So there is nothing mentioned specifically in NFPA. It could be half a meter, it could be 100 millimeter or 200 millimeter. So there are things that we can improve even over and beyond NFPA 130. There are other aspects of NFPA as well that we can talk about. Because of the time, I cannot really go through the details, but I encourage every one of you guys to actually read that with a critical eye. So if the system is NFPA compliant, doesn't mean that we cannot improve. There is always room for improvement. NFPA and codes are the minimum requirements. Now let's see if we can actually go and do something about the pandemic. Why actually I am talking about this and why did I get into that? Funny thing, when the pandemic started, lots of colleagues, operators, owners, lots of my friends came back to me and were asking the question, oh, can we use the emergency fans to actually do anything about pandemic and about air circulation? So we were thinking about that and we were considering different options. But one of the first things that we thought is that people are not in the tunnel. People are mainly in the rolling stock itself. So let's see if we can actually do anything about the rolling stock. So We chose a real rolling stock in service. I'm not really telling you which system, but there is a real, the model that we did is based on the numbers from an actual rolling stock. For the particles of coughing and sneezing, we choose the published data for particle size and velocity, and then we used CFD modeling. So on the left side is the actual existing system. So there is a supply in the middle and the two returns on the end. We are assuming that we can change the system to something like the system on the right side. So we put the supply on the side and we put the return on the middle. And then we used CFD to model. We actually have some fancy videos. If you are interested, you can contact me. I can possibly even send you the videos if you're interested, but I'm just presenting you the slides. On top, you will see a person sneezing here. Just one note. No, we did not model the mask because we are thinking about the future, probably few years or few months down the road that the mask is not required anymore. So we did not model the mask. So on top is the existing systems. You see how particle goes everywhere. On the bottom is the system that we are proposing. And you can see that actually the air is kind of blocking the air like a wall. So, and all the particles are going up to the top. Let's look at the coughing. Coughing is even worse. When you cough, you can see that how particles are moving everywhere in the vehicle. And with the proposed system, you can see how effective we can actually capture all the particles. It's not a bulletproof system. It does not address everything, but it shows that conceptually we can improve the system drastically if we do some changes. So it's really a point of thought for owners, operators, and vehicle and rolling stock manufacturers to look into that. With that, I will go to the conclusion. So based on the presentation today, fire in transit is a major risk and it's a real risk. Compliance with the code and NFPA building codes, local codes, it's definitely a good mitigation, but it's not the end of the story. We can always improve based on our project needs and requirements. Also, to provide safer and healthier system in transit and making sure that riders are confident and coming back to the transit again, we can definitely work on the HVAC system and do some improvement on the system design and how the system provides fresh air and supply and return air. What we presented is not, as I said, is not a bulletproof solution. It's just the proof of concept that things can be done differently. With that, I thank you everyone for joining us today, and we are opening the floor now for questions. If there are any, I'm more than happy to answer.
Thank you, Nima, for your presentation. So just mentioning the housekeeping items again, you can log your questions in the question box on the GoToWebinar platform, and also you can download the PDF version of the presentation from the handout box on the dashboard. I will start with the first question, where the person here is asking to clarify the once every 15.4 years. Is it per vehicle or is it estimated for the whole fleet?
The calculation is based on one vehicle. But the whole fleet is actually the calculation is based on every vehicle that moves, so to that few million kilometers per year.
Thank you. Next question is, what is your view on water mist system in the tunnel as a safety feature?
It's a very good question. If you're asking my personal opinion, if we want to go water mist, I recommend to put water mist system inside the vehicle instead of having it inside the tunnel. It's more efficient, it kills the fire at the source, and it's very much more cost effective.
Thank you. Next question is how the functional integrity is maintained for the emergency circuits and ventilation system inside the tunnel and building.
Okay, so NFPA actually has a very good requirement regarding that. One of the things is that all of our emergency system needs to be redundant. So we can not only have, for instance, one PLC box and one PLC. It goes out of power or something, and we lose the whole tunnel vent. So everything is redundant. Cables should be in fire-rated places like concrete walkways or in a fire-rated conduit. All the tunnel ventilation, electrical system and equipment should be in fire-rated rooms, at least for 1 hour or for the time of tenability that we calculate. We have always include a fan failure case, for instance. So if one of the fans that we are designing for tunnel vent doesn't, so there are lots of requirements to make sure the functionality and integrity of the tunnel ventilation and fire life safety systems. If you have more questions, please let me know and email us. I can actually elaborate on that.
Thank you. Which NFPA should be used for critical velocity? Is it NFPA 502 2002? Sorry, 502 2000 or 502 2017? Sorry, we lost your slides. We see your desktop.
I know. Sorry about that. I will do that in a second, I guess.
Oh, perfect. Thank you.
Thank you for the questions. Yes, one of the things that NFPA 130 doesn't have is the critical velocity calculation. We always use NFPA 502. There has been some recent changes in NFPA 502's critical velocity calculation, but yes, as a reference, I use NFPA 502. If there are other newer research, there are lots of actually discussions that NFPA 502 may not be the best. There may be higher velocities required, but the research is still going on. But at the moment, NFPA 502, I guess, is the reference for works that we normally do.
Thank you. Next question is, what about fire-rated doors for fire-rated rooms? I hope I read it correctly.
Okay, so I'm not really sure what you mean by that. What about fire-rated doors? We want fire-rated doors for all critical rooms. For instance, any room that is used for egress, for instance, EEPs or cross passages, they need to have fire-rated doors. The rooms that actually are pretty much holding in tunnel ventilation related items or electrical or safety critical electrical items, they all should have fire rated doors. I'm not really sure if I answered the question or not, but I hope I did.
Thank you. There's a question here about extreme hot temperature, how to prevent buildup of fire in highway, roads, and tunnels if there is extreme hot temperature.
Okay, so roads and tunnels, although it's not based on NFPA 130, they all go by NFPA 502. But for road tunnels, we have we design a tunnel ventilation system as well, mostly with jet fans to be able to move the air and to pretty much to move the smoke. We normally don't use them for high temperatures, but if you're in a hot area that we possibly have really built up of heat in the tunnels, we can certainly use those jet fans to turn them on to bring fresh air and send the hot airs out. However, generally speaking, the tunnel itself, if it's for instance, if it's a kind of an underpass breach, all the elements should be fireproofed and fire rated at least for 1 to 2 hours, while the emergency crews come in and they pour water on the fire and try cooling things down, but they all should be fire rated as well, based on the code.
Thank you. Due to the time, I will just take the last question. Any additional questions will be answered directly by Nima. So is tunnel ventilation taking into effect the vehicle movement and any drought effect created by it?
Okay. When we designed the ventilation system for a tunnel, we have actually a separate set of calculations and simulations to actually see how the air moves when the vehicles are moving in and out of tunnels and stations. We make sure that fresh air is coming in, enough fresh air is getting exchanged, and we have enough ventilation shaft to send the air out of the tunnels to make sure that we are not over pressurizing the stations. During an emergency, we assume all the vehicles are stopped because we stop all the vehicles operation in the tunnels. So technically speaking, we don't really need to consider the air movement by the vehicle during an emergency, of course. During normal operation, we do that calculations, yes.
Thank you.